Let's take a look at how else we can use tangent line approximations. And remember, long ago, they did not have access to the fancy calculator that you have. They had to use other methods whenever all of this calculus was built. They had to use other methods in order to come up with valuable and viable solutions. So this is one of those examples. We're going to use the tangent line approximation to approximate the value of the cubed root of 127. The way we're going to attack this is we're going to use the cubed root of x as my original function. We're going to choose a perfect cube close to 127 and build our tangent line from there. Let me show you what I mean by that. I have f of x is equal to the cubed root of x. I can also write that as x to the 1/3. I know I'm going to have to take a derivative at some point, so that would probably be valuable to me. I am going to use a perfect cube that is somewhere close to 127. I want to use 125. So we're going to use x equals 125 to estimate or approximate what the value is going to be when x is 127. So the idea is f of 125 is obviously equal to 5 because that is the cubed root of 125 if I plugged in a 125 here. I now have a point. I need a slope to go with that in order to be able to write the equation of a tangent line. So let's go back and deal with slope. Slope means derivative, right? F prime of x is 1/3 x to the negative 2/3. I do need a little bit of a rewrite here. So I feel pretty good about that derivative. I don't want to know the slope at any spot. I want to know the slope when x is 125. So 1/3 times 125 to the 2/3 power. If that 2/3 power doesn't make a lot of sense to you, you can write it as a root. It is a cubed root, but the 125 is squared. Be careful about this. Please don't try to square 125. I don't want to do that. I'm trying to do all of this without a calculator. So I want to cubed root 125, which is 5, and then I want to square that. The order of these, they're both powers. So the order of them doesn't matter. I can do this one first or I can do that one first. So cube root first, then square it. Looks like this is going to be 1/3 times 25, or 3 times 5 squared, which is 1/75. That's my slope. So let's write the equation of the tangent line here. I'm going to start off with y minus 5 is equal to the slope, 1/75, times x minus 125. That's how I've always written the equation of a tangent line. But remember, we want to be able to manipulate this. So we're going to move that 5 over. And we're going to write this as 5 plus 1/75 times x minus 125. Now, what am I trying to approximate? I'm trying to approximate what is the function value when x is 127, right? When a 127 is in that cubed root. So now I'm going to use that. I'm going to say f of 127 is approximately, and I'm going to plug in a 127 everywhere there's an x here. One more rewrite. That's 2/75. You can leave it like that. You can obviously do a little bit of fractional manipulation if you would like to do that. If you have access to a calculator, then obviously we wouldn't be just using this, but understanding the process is the key at this point. But if you plug this into your calculator, I think a decimal approximation is valuable here. So this is my approximation for when x is equal to 127th. That's about what I think the cubed root of 127 is. But again, your calculator is pretty fancy. It is basically a computer in your hand. So we're going to find the exact value by taking 127 to the 1/3 power in your calculator. You need to be able to do that. And you get 5.0265 If you don't know how to do that, I would practice that in your calculator. You need to be able to do that. Therefore, the error is going to be 5.0267 minus 5.0265. Again, the order of that does not matter because I'm doing absolute value signs. So I'm going to end up with 0.000141. I kept a couple of extra decimals in my calculator here to make sure. Y'all, that's a pretty good estimation. I'm really close. But it depends on if I'm trying to send a rocket to the moon. Like, that's not good enough for that. Something's going to be off. Or if maybe I'm estimating something else. Maybe there's some sort of financial situation. Well, that's not even a penny. Right? So there's different value to these estimations depending on what you're applying.